good afternoon. I'm Prince213, or you can call me by my Chinese name, 是国内第一次以. Today my topic is about how to host mirrors without NixOS, aka life without Kubernetes. So first, this is the outline of today. Okay, let's skip this. So who am I? So first line is my GPG user ID. The second line is my personal website. I'm currently a Nix packages maintainer and the president of the JIGPI Association. I'm the lead of the school's Linux user group, LUG. And I'm currently at the SRE role for our mirroring infrastructure at mirrors.shanghaitech.edu.cn. So it's kind of an official project. I'm also host of this conference, NixCN Meetup 1, and I'm now available for hire. So if you have job opportunities, you can contact me. Okay, first one. So what's the situation of our current infrastructure? We have two machines with Kubernetes. The first one is called Milky Way. The second one is called Andromeda. They both run Debian Trixie, which was the testing. The new version was just released yesterday, but well, at the time of writing, it's still in testing. Milky Way provides public service. It has a HTTP server. It has Nginx ingress controller. And it also acts as the control plane. So all of the K8s configurations are on it. Also, we have Andromeda, which actually handles the storage. We have a ZFS release Z configuration. And we mount this as a native volume and share it via NFS. It also acts as a work node for the backend syncing, which we have an in-house syncing backend. We forked from SJTU UG. It manages tasks directly, like when to start, when to stop, what happens if it failed, like restarting, etc. And it also provides a RESTful API for the front end. Like when you click on the site, you can find that it says the mirror is in sync, or it's syncing, or it has failed, right? Okay, what's wrong? The biggest thing is Kubernetes. Kubernetes is, you have a lot of new concepts to learn. I've just listed a few, like config map, service, and namespace. But there's also pod and other things that are far beyond general container operation. You need to know much more to act this efficiently. And it's only suited for large-scale deployments. Say you have 3 or 4 machines, that's not enough. You need at least like 50 or more than 100 before it actually becomes useful. Which is also why I have the third point, is that the configuration is very complicated. For example, if I want to start a simple container, I don't just start it. I need to write a YAML file that says this container belongs to a namespace, it's in a pod, and I want it to run on a certain machine. So that's too complicated. I just want to start a container on one machine, right? The second thing is container itself. First, it's required by Kubernetes. You cannot start a normal Unix program. That will not work. Also, it provides unnecessary isolation. Like, if you have some untrusted binary you want to run, Docker might be a good idea. Or if you have some public-facing service, you might want that. But if we are just doing mirror syncing, we only run the rsync or git clone. So that's really providing unnecessary isolation. And you have to mount the volume, so it's more complicated. And also, Docker is not free software. It's free, as in free beer, for personal use and non-commercial. But when you have a large-scale deployment, like commercial ones, you need to pay for it. And the fourth thing is that Docker images are impure by nature. Okay. Also, about the operating system we have, the Debian Trixie, which was testing at the time of writing, it's hard to track the state, which is particularly like all FHS compliant distros have. Is that you have a lot of configuration files in /etc, and you don't know what to do. You cannot track it. You don't always have the ability or will to track it. Also, Debian has outdated documentation, which is very bad. Like, it's even worse than missing documentation, because an outdated one can be misleading. It can contain, bad practices that we don't consider as good now. Okay, the fourth one is the syncing backend we have. It's an in-house one, but it's forked from upstream. And upstream is basically going away from this. So we are now the upstream. So that's bad, because we don't write the code initially, but we need to maintain it. And also, it tries to do too much thing at a time, which is inviolate of Unix philosophy, if you care that. All right. Also, I want to give an example on why Kubernetes is complicated, because all of our services, which we have quite a few, like 10 or so, they all specify which machine to run, which means the high availability thing won't actually be useful because you already said that I only want to run it on this machine. And also, why it's complicated is because, for example, I can take another example. The Nginx, our mirror ingress is controlled by Nginx, and it has a configuration that is loaded into the container via a config map managed by Kubernetes. So whenever you update the configuration, you will also want to update config map. And Kubernetes will automatically restart the service for you. But in the past 2 years, many of my colleagues have modified the configuration file, but none of them actually remember or know to sync the new configuration into config map. So what we have is that when I did this, it kind of crashed because someone introduced a broadly compression directive into it, but the image we use do not have this support. So Nginx will just crash and say, you are trying to use broadly, which we don't have in this image. So that's really, really bad. And it's something that you feel terrible. Like, why is it so complicated? Our demand is simple, right? And also about why Docker images are impure is that we have a common practice of running apt update and apt upgrade in the first few lines of a Docker file. And that's essentially impure. Like, it might work, but it's not reproducible. So this is when Nix and NixOS come into handy. Okay, we have impure Debian, we have complicated Kubernetes. So our way is to use Nix and NixOS, which is very much in line with the topic of this session. And we try to orchestrate with systemd, so we don't use Kubernetes. And Nix also acts as a declarative configuration as a single source of truth, and you no longer have to fiddle in / etc. Also, containers have an unnecessary isolation, which we discussed earlier, so we'll be using systemd services instead. And they are generated automatically by Nix from our configuration, which is a JSON file, and specifies what's to run at what time, what command, right? The last thing is that our in-house sync backend is huge. We are the upstream, and we don't write the code. So we'll instead let systemd handle the task. Systemd handles when to start, what happens if it fails, and we just ask systemd what's the progress via debug interface. Okay, first about Nix and NixOS. It's declarative, so we have infrastructure as code, but also it's very easy to comprehend, so we also have code as documentation. The second thing is that with Nix, you have unified configuration, and Nix is not hard. Nix can be as simple as JSON++, which is a weird, you can think of Nix as a weird JSON, right, with a weird format. But it can, in the meantime, it can also be powerful with functional programming. You have monad and those weird functional things, new concepts. They're all at your hand if you want. And you can also have reusable configurations because everything is configured in the Nix language. So you can share this across services with different configuration languages. For example, WireGuard has its own INI-like format. Systemd service has also a different INI-like format. And you cannot share if you just don't use Nix. You have to remember that whenever I update the code in one place, I have to update in a different place, which, of course, everyone eventually forgot. So they can go out of sync, but with Nix, you can just use one Nix file, import this in 2 files, and it works, right? Also, it can share across machines. Like if two machines have, say, we both want to enable a WireGuard network, we can use Nix to do this and import the same module in 2 machines and it works correspondingly, which we'll see later in our implementation. The last thing is that NixOS container is lightweight and it provides enough isolation. Like, it's not as good as Docker container, but it's pretty enough for most uses. Okay, the next thing is about systemd and our syncing backend. So first thing, it's kind of bold, but systemd is the system manager. I mean, someone might gonna disagree with me and say systemd is bad, but you can't really get rid of systemd in NixOS, so we're gonna live with it. And it also has nice features. For example, systemd.timer controls, or to say schedule the task, like when to start and those things. It also has a dbus API that is not provided with old style system 5 style in it. And it's also well integrated with the rest of the system. For example, I want to start a task only after network is online, which you can do this with the systemd wants or requires directive. So it's pretty convenient. And as for the sync backend, we are providing a rewrote with a simpler design. So previously we let the syncing backend to manage all the services, but we now use systemd. So it's much simpler. We only need to provide a very thin layer over the dbus interface. So we just fetch the status from systemd and provide a RESTful API. So this is a very simplified overview of our implementation. So the actual code is much more complicated and much more structured. So, but here we just put everything in the same default.nix file. Okay, so there's a few things interesting that I would like to share. The first is how we implemented a full mesh WireGuard network. This is a simplified implementation of everything needed to get one up and running. We have this networks.nix, which basically has a configuration file of, it's an attribute set whose attribute names are name of each machine, like the host names. And the values has this many fields, like address, public port. So what we have is that a different machine imports this file with the name argument, which basically says I want to configure WireGuard for this network. And we have is that we automatically import the corresponding file, which contains a list of all peers. And we first filter out like all the other peers beside myself, and then I generate with Nix of a list of peers. So what we have now is that you don't need to manually add each peer to other peers' configuration. You can just import this and write a single new peer in the network name.nix, and it will work. Zero configuration. You only need to write once. Okay, the next is Nix-generated systemd managed tasks. Here is a simplified view of what we have. Basically, this is now handled by JSON file, but the things are the same. Basically, you have a list of tasks, and you just generate systemd service for each of them, and it will work. You just specify like in the JSON file, and the format is like this. So the key is name of the Miro project you want to sign. The script is what you actually execute. And start at is a systemd timer instruction for when to start. A daily is an abbreviation for at midnight at local time each day. The next is the syncing backend and systemd dbus API. This is a Rust project. And Rust project is well known to be easy to build. You only need to say cargo hash and everything is done. This is the main entrance. We have Tokyo. We have Tokyo for async functions at the runtime and Axiom for HTTP server. The code is easy to understand, albeit pretty noisy. I know Rust is very annoying, but afterwards it's pretty good. This is how we actually ask systemd for this. We use ZBus, which is a Rust implementation of dbus, the entire client and server API. And what we have is that there's a proxy generated with macros and tells us, we just give it a connection and pass the unit, and we can just exit. This is like, what's the last exit status of the main process? When does the last process exit? And it is still active. So this is what we have. We just only need these three results, and that's pretty compliant with what we have now, like what the existing front end requires. So a bit of reflection, pros and cons. The cons are we lost support for zero downtime update and high availability, but it's not that important. Our school network is already pretty bad. Every downtime accident can be up to 50 minutes, which means our yearly SLA is impossible to go to 99.99%, which is 52 minutes and 36 seconds. And our quota this year has already been used. I think this year's downtime has been well over 55 minutes, so we're cooked. So let's see the next one. So we lost scalability and other cluster features that Kubernetes can provide. That's also not important. We only have 2 machines, whatever, and everything is binded, so don't really care. The third one is that what you have, the knowledge you have on other distros will not be applicable to NixOS. This is pretty important because if you already have a big project in a big company, whatever, and existing things are complicated, you do want to migrate your knowledge. But we have a rather simple project, and essentially it's a one-man project because no one else is doing this kind of work. So I am the sole responsibility taking that for this. And my solution to this is I'm promoting Nix and NixOS across my team or my colleagues. And the result is that like most people, I think only 1 or 2 are exception, they are using Nix and NixOS. Even if they have Macs, they'll also be using Nix Darwin or even Asahi Linux. So that's not a problem. Everyone in our team know Nix, even NixOS. And what we got for the good side, we have stable rolling updates and easy rollbacks. Debian testing is kind of rolling, but it's not stable, right? The stable rolling feature is more like void Linux, but Nix is kind of more aggressive in this sense, and it's less. It's harder to break. And rollback is very simple. Just have NixOS rebuild rollback, and it works, right? The next thing is a unified and declarative configuration. So this is, I don't think I have to explain this too much, but Nix is one language for everything. The next thing is code as documentation. The Nix code is pretty self-explanatory, so you don't really need to write separate documentation just to explain how the code works. I mean, if you don't use functional programming magic, that is. And the last thing is that we have a lower maintenance cost. There's only a few Nix files. There's no secret hidden files in /etc that was overridden by the drop-in in a /run file, /run folder. That's not exist. What takeaway can we learn from this lesson? First is that Kubernetes is not the silver bullet you want. It does not work for all kind of deployments. And especially if you don't have many nodes, it's just asking for trouble. Because if you spend too much time on tools, you have no time for actual work. The next is that Nix and NixOS is not that hard. JSON++ conforms to the Pareto principle, which is also called the 80-20 rule, that most of the time you're just writing a weird JSON. There's no need to know functional programming, no need to master it before you can actually get on to work. The last thing is that documentation is important. Nix implements code as documentation. But additional documentation is also very important, like how different machines interact, how is the network topology. And what we have is that we have a Nix topology graph generated for all the machines I manage and all the machines of the school. So you can see if you have the graph, like how the WireGuard network connects to machines, how to route things, like what's the IP address, what's the public interfacing ports, and what's the physical port they have. So they're all documented, so it's very good. And basically that's it for today. It's a bit faster than I expect. A few acknowledgements, thanks to Xidian University. They have a implementation in a Python one of the systemd service generator, the entire idea. I have this idea earlier, but it wasn't until AOSCC 2025 that I realized someone has already done this before. But it's in Python, and we're doing this in Nix, so we're still kind of like first in this field. And also to salute to these people for creating the background I use here, this blue one. They also have a white, black, gray one, if you want, for a nice theme, which is licensed under CC BY-SA 4.0. And that's it for today. Any questions? Yeah, so if you could hand Max.
Okay.
你说中文就可以。
No, I want to practice my English.
Yeah, okay.
Okay. I'm discovering to manage my home lab by to use NixOS to manage my home lab.
Yeah.
My question is that we have many hard disk and each hard disk has different UUID. As usual, we write the UUID into the hardware configuration while we installing NixOS.
Yeah.
But as a NAS or a storage server, we need to we meet some question when we change the hard disk. So how do you deal with the question?
Oh yeah. So your question is that each disk is specified by UUIDs, but what happens if we change hard disk? And that's kind of has happened, here, probably here. Our storage server has more than 30 disks, and the way we have is that, there's UUID. When you speak of UUID, you have two options. The first UUID is the UUID of the file system. The second ID is UUID of the partition table, and what we have is that we don't actually consider each disk that different. So we just say that we have a list of names like disk 1, disk 2 to disk 31, and we reference this by using label, right? Not part label, just label. And also, I'm very much advising you against using a path, like a WWN for this. Because when you change disk, it will become invalidated, and it's pretty bad. You have to change it and rebuild the system. We also plan to use disk code to declare everything of this. I mean, we don't need to reformat the disk, but disk code can have you generate the file system thing and auto mounting, so there's much less to worry about. I hope this answers your question.
Okay,
yeah.
Thank you.
Sure. So who's next? Yeah, please.
So for my usage, especially on server usage, some server apps don't have every configuration that can be declared, and you may have to append the config like ini or YAML by appending string in your Nix configuration. And in this scenario, you may even lose the schema like the JSON schema you can use in VS Code. So it makes the configuration more like the complicated.
Okay, I see your question. Yeah.
How to deal with that? Because you can't declare every aspect. That's true.
So you actually have two questions. The first question is that what happens if we use Nix to configure things, because it's not JSON, so you can't have JSON's language server and JSON schema.
I know, but now I know that you can use Nix to declare that, but not every packages you can override, or you may need to use some functions like extra config and use string to append.
Yeah.
So in that scenario, that's complicated.
It's actually kind of like 2 or 3 questions. The extra config thing is actually what we are trying to improve in the RFC 42, if you could search. It's called structured configuration, and it's designed to handle the cases where we can't generate the file, but we can't document all options. So that's one way forward. So you don't have extra config, you have extra settings, which is declared like a JSON value or something, a nested submodule, so kind of handle the thing. And you can import the JSON file into Nix, so you can still write JSON if you want, and I do recommend, because sometimes your other tools might also consume JSON, and you don't want to use Nix as the single source. You want to write a JSON and import it into Nix. And the other problem is that we cannot declare everything, right? This is expected. You cannot declare everything. It's impossible. So what we have that we declare as much as possible with Nix and use documentation for handling the rest. I mean, even if the file cannot be declared, it still has a well-known place to store, like in etc. or something, which is when we can have Nix handle this. We just commit the configuration into a source control, or encrypt it and commit it into a source control with subnix or something, and we have a etc.something send link. So we still put the configuration file with the rest of the config, albeit not using Nix. Yeah.
And for mirroring scenarios, I think Nix don't have its ability to work in very bad network scenarios like in my school's LUG holding mirror sets, the outbound traffic is always at a 800 Mbps per second.
Oh, that's
maybe.
faster.
Yeah, it's faster, but it's high load. Its loading is very high, and sometimes the updating is impossible. Syncing itself always sometimes fails, and I don't think fetching from Nix is possible in my school. How do you deal with that? My network is bad. I can't fix that.
I think your school has better setup. We have, I remember outbound is limited at 100 megabits per second, so it's much lower than 800. And the networking is also the issue, but you don't really need to have 100% synced locally, right? We also have remote. You could have a reverse proxy to the upstream, and even redirect your traffic to other mirrors if you're that bad, without noticing other parties. It's possible. So networking, it's really isn't that much of an issue unless you're a perfectionist, which you will want to always sync successfully, and it's impossible, right? Because let's just take Nix as example. When I do have a Nix channels mirror before a few months ago, and the thing we have is that everything it will fail midway, and often like only after 1 or 2 hours into the syncing, you will know that it fails. So you have to keep retrying until it succeeds, and the entire process, starting from an empty disk. I remember it takes well over 24 hours, which is pretty bad if you want a daily sync, right? So it's kind of bad, but we can live with it. We do have other mirrors available, so I suggest that if you want to do this, you don't start worrying about like 100% completeness immediately. Like get it to start first, and then consider how to improve. Yeah. Do we still have time for questions or?
还一个问题的时间。It's a great presentation, but I want to ask, like, will the configuration of the mirrors will be eventually shared to the public, like under a repository on GitHub or something?
Yeah. I do have this plan. I mean, it's no secret. Nix is not a secret. And I do want to share this across the Mirror League we have across the country. So, well, ideally, other universities should also use Nix. But it's hard, it's daunting. And currently the code is still not cleaned or like structured enough to be published. But I do eventually hope to make this public after NixCon perhaps. Like we still have 1 month away. So after that I should be able to publish this in a polished and ready to use manner. Currently you only have access to the code snippet I showed, but later you should have access to the entire source code, like how we actually implemented, right? Yeah.
Oh, and what's currently stopping you from like hosting a Nix mirror on the school's infrastructure? I don't currently see it on the website.
Nothing really, you know. There are some existing Kubernetes infrastructure that actually stopped me from reinstalling the entire system into NixOS. But other than that, I think there's no real stopper, you know. If you want to avoid network issues, you could even sync from SJTU if you want. So no, there's no real obstacles. So we can do this like after the meeting or something. It's possible, right?
Okay, thank you. I see.
I guess that's it for this session. I would like to thank you all for listening to this.